In this video, we're going to talk about solving systems of equations, this time with 3x3 determinants. All right, now I could show you the rules with all the variables, A, B, C, etc., of how to find the determinant of a 3x3 matrix, but I'm going to be honest, I think the easiest way to do it is to show you with an example. So there's a couple ways that you can approach this, but the easiest way and the one that I like the best is to do the following. So let's say I have this 3x3 matrix here, and I can find the determinant because it's square, same number of rows, same number of columns. So what I'm actually going to do is I am going to rewrite my first and second column here to the side. So that's going to be 3, 4, 8, and 0, 6, -2. If you're a messy writer, please make sure that you pay very close attention to line these up. It will save you. So what you do in a 2x2 is you would multiply down and then subtract whatever you multiply across. It works kind of the same way, except I've got more things to multiply here. So how this works is you multiply these three going down, so that's 3 times 6 times 3, and that's 54. So next you do this diagonal, so that's 0 times 2 times 8, so that's 0. Then the last one is -1 times 4 times -2, and we add that, so that's going to be +8. And when we move in the opposite direction, we're going to subtract each time, just like in a 2x2. So this is going to be 8 times 6 times -1, which is -48, but we're subtracting it, so that becomes addition. Next one, -2 times 2 times 3. That's -12, but I'm subtracting it, so it becomes +12. And then last but not least, we got 3 times 4 times 0, and anything times 0 is going to be that. So when I algebraically work this out, my determinant is 122 for this 3x3 matrix. So now let's talk about Cramer's rule for a 3x3. Now in a 2x2, I took the determinant of the x matrix and the determinant of the y matrix, and I divided them both by the coefficient determinant. So the same rule applies here, except now I have a y coordinate. Because it's a 3x3, it's going to be in 3D space, so it's going to have an x, a y, and a z coordinate. Now remember that we cannot have a 0 in our denominator or a 0 determinant of our coefficient matrix. So if that happens, then we have no solution or infinite solutions for that system. So Cramer's rule doesn't work there, just like in the 2x2. But if we look at how it's similar to the 2x2, I replace my x here with my constants. I would replace my y with the constants and the z with the constants. It just takes a little bit more work, but it's the same process as a 2x2. All right, you ready to see this in action? Well, let's go. So the first thing that I'm going to do is I'm going to find the determinant of my coefficient matrix. So that's going to be 2, -1, 1, 1, 2, -2, -1, 4, and -3. So I'm going to use what I did a couple slides ago and find the determinant of this. And the determinant of the coefficient matrix is 5, so I'm going to divide by 5 in my determinant of x, y, and z. So I'm going to write those out now. So what I'm going to do for this x value is I'm going to replace them with the constants here for x, because I'm looking for the determinant of x. So I'm going to work some movie magic here and find the determinant of that. So the determinant of the x matrix is 15, and I'm going to do the same process for the determinant of y and the determinant of z. So you can either use your calculator to actually determine these determinants, or you can do it by hand. So what I found is that the determinant of x is 15, and I'm going to now divide that by the determinant of my coefficient matrix here. So if I divide that by 5, I get 3, so x equals 3. I'm going to do that for y. So y is going to equal -2, and then here z is going to equal 1. So the solution that I have for this system is going to be 3, -2, 1. And that's going to do it for this video. Thanks for watching.